Alright, let us look at another problem related to heights and distances from the chapter Applications of Trigonometry. A ladder rests against a vertical wall at an inclination alpha to the horizontal. Its foot is pulled away from the wall through a distance p so that its upper end slides a distance q down the wall, and then the ladder makes an angle beta to the horizontal. Show that p upon q equals cos beta minus cos alpha divided by sin alpha minus sin beta. So first I'll try to draw a rough diagram and explain what the numerical is describing. So let's say this is a vertical wall and this is the horizontal ground. And let's say this is the ladder which is initially at an angle of alpha with the horizontal. Now what happens is its foot is pulled away from the wall, which means we know this is the foot of the ladder and this is the wall, which means if its foot is pulled away from the wall, this is the direction in which the foot of the ladder moves. Therefore, let's say this is where the foot of the ladder lands, and this is how the new profile of the ladder will look like. This new angle is beta, and we are told that the upper end of the ladder slides down by a distance q. That means this particular distance is going to be q, and the foot is pulled away through a distance p, which essentially means this distance right here is p. So this diagram right here describes the situation of the ladder, its foot being pulled away from the wall, its angle changing from alpha to beta, and we will use this diagram in order to solve the problem. Now this diagram is representative of all that is given in the numerical. The only extra variable that we have added is L, which is the length of the ladder. It is noteworthy that the original length of the ladder, which we are taking as L, remains L, because no matter where the ladder slips to, the length of the ladder remains constant. So we call the length of the ladder as L. So we'll declare that right at the start, and we say let L be the length of the ladder. All right, now if you notice, what is being asked is p by q is equal to cos beta minus cos alpha over sin alpha minus sin beta. So makes sense to find out what these cos betas, cos alphas, and sin alpha and beta are. So let's first take up cos beta. If you look at this triangle right here, cos beta is adjacent, which is x plus p, over hypotenuse, which is L. So cos beta is x plus p over L, and cos alpha, which pertains to the smaller triangle, would be adjacent is x and the hypotenuse is L. So cos alpha would be x divided by L. Now if you look at sin beta, again sin beta pertains to this larger triangle, which means opposite, which is h, divided by hypotenuse, which is L. So sin beta is h over L, and sin alpha, if you look at this triangle, sin alpha would be the opposite, which is q plus h divided by hypotenuse L. So this is q plus h divided by L. Now let us write the right hand side of the expression which we are asked to prove. Cos beta minus cos alpha divided by sin alpha minus sin beta. So cos beta is x plus p over L, cos alpha is x upon L, whole divided by sin alpha is q plus h upon L minus h upon L. So we notice in both the numerator and denominator, this is the same, L is the same. So the LCM would be L, and we would get x plus p minus x by L whole divided by q plus h minus h over L. So the plus x minus x and the plus h minus h get cancelled, and so do the L's. This results in P upon Q, which is the left hand side of the expression. So therefore RHS is equal to LHS, hence proved.